Narasimhan
Thank you.
and Nagaya Garu.
Thank you.
And good evening to all mathematics teachers and mathematics lovers. Today being a special day, December 22, there are two specialty of this day. One is, it is called winter solstice, the shortest day in the entire year. That means the longest night day. And you know, it is a birthday of the great mathematician Sri Srinivasa Ramanujan. The National Mathematics Day was first proposed in 2012 by our former Prime Minister Manmohan Singh on as December 22 on the birth anniversary of Sri Ramanujan. Now, to begin with, what I would like to say is to invent something, to become great, your age is not a limit. You do not be a very old man or a senior man or having high experience. In mathematics also, we have several people who have lived a very short life, but invented a lot. The first one is our Indian famous mathematician, I think everybody knows, is Aryabhatta. He is the beginning of our mathematics in Indian history. He died at the very short age of 40, 44. And you know, Adi Shankaracharya, although he's not a mathematician, he's a philosopher, which is a part of mathematics. He's also died at the very young age of 30. And you know, everybody knows who has done research in algebra, Everest Galois. Galois died below at the age of 20 years, who has invented a very popular subject called Galois theory, and everybody might have done in MSc classes. Similarly, Abel's theorem, you know, he's also died at the young age, but invented a lot of contributed a lot of mathematical contribution. Similarly, Urjan, everybody knows Urjan lemma in topology. He has a lot of contribution to mathematics at the very young age. Gautek's differentiation comes in differential geometry, where he's also as a new type of differentiation died at the very young age. Riemann, Riemann, he is a Riemannian geometry and Riemann-Roch theorem in algebraic geometry and so on. That Riemann also has done a lot of contribution. He has died at the young age. Frank Ramsey, in the way our great Indian mathematician Srinivasa Ramanujan, who has done a lot of contribution to mathematics and its applications. He is died at the age of 32 and he has contribution a lot. I need not tell many things about Ramanujan, but everybody knows from the day in the beginning, everybody talking about Ramanujan. He's so much great that my introduction to him is not at all necessary. Ramanujan is a self-taught mathematician. That means, and what I mean to say is, he doesn't have any big degrees like us, MSc mathematics, PhD mathematics. He is only a graduate in mathematics. He is a BA mathematics. And you know, he learned mathematics as somebody learns in music, who becomes popular in music. They did not have degrees in music, but they become world popular musicians. In the same way, Dr. Ramanujan has done his mathematics as a passion and invented so many identities. And that, you know, all that story is there. He was impressed by Professor Hardy and he invited the university and where he has done a lot of work and so on. So Ramanujan's contribution, I mean, what he has done, and everybody knows is the Ramanujan number, Ramanujan this one. So Ramanujan's conjuncture is there on the size of tau function, which was conjuncture means a theorem which is not proved for a long time. It was only proposed. And Ramanujan conjunction on tau function was there pending for several years. Only in 1978 it was proved by Dirichlet. And he has worked on infinite series of 1 by pi, e power pi 25, and partition of functions, all these lot of books. This entire work of Ramanujan is, and the work which has left incompleted was available in a book called Lost Notebook, which was, written by Hardy himself at Cambridge University. So in that last book, you can see. What I sometimes think that had Ramanujan has not died at the age of 32, had been alive for 25 years more, how much mathematics Indians contribution would have been there. How much, how many people of as his students would have been there. So that I can't imagine. So God has taken him at a very young age, and it is a loss for our Indian mathematics. And the government of India, it is declared as National Mathematics Day, and 2012, and then a stamp of Indian stamp also released on Ramanujan's Day. And there is a Ramanujan's Mathematical Park is opened in 2017 at Kuppam, Chittoor by then Andhra Pradesh government. So a lot of tributes have been given to Ramanujan, and I'm a very small man to talk about Ramanujan work. You are already on the number theory. Professor V. Srinivas has given an excellent, talk about on the number theory, which was very useful for our young researchers. Since my field is elasticity and little operation research, so I may not speak about on the number theory and so on. So he and although Ramanujan has died at done a lot at a very young age, he died with a pneumonia and hepatic amoebiasis in 1920 at 1227 at Kumbakonam only. All this story, everybody knows it. And 135 years back, man, we are still remembering, and everybody should have motivation. His talk, his subject, and he has motivated many people. Being a student of University of Hyderabad, we had a sufficient book collection was available in the University of Hyderabad. Full Ramanujan's collections were there, collected by Professor Kannan of the University of Hyderabad. One can go to that library and see what exactly Ramanujan has done. And his subject is a very tough subject. You should have a lot of basic knowledge in the subjects like analysis, complex analysis, basic algebra, and number theory, and so on. So I feel I hope that many of the young mathematicians will work in that line and bring name and fame to our country in the subject of mathematics. At the end, I thank Mr. Professor Narasimha Swami Garu and Nagaya Garu to give me a small opportunity to speak to your young mathematics teachers and mathematics lovers to talk about on this auspicious day for our mathematicians. It is a festival for us, a special day. So that is on December 22. Hope everybody has know something from me. This. So Ramanujan's work, everybody must look into that. At least what is his contribution. His work is not so difficult. There are some basic identities he has used. He has not used a big mathematics. He has used the basic mathematics only. Using basic mathematical identities like algebra, trigonometry, and others, he has contributed a lot of identities. He has developed a lot of identities like convergence of power series and so on. So I thank everybody for attending and listening me carefully. Thank you very much.
Thank you, sir. Prasad?
Sir.
Thank you, sir. Prasad.
Thank you, sir. Myself, Prasad, sir, Shatavan University, sir. We met in Shatavan University in 2 conferences, sir. We have invited in 2018, sir, in conference, Tandon, there, Tanvan was there, sir, in the conference. Who came there, sir, in Shatavan University, sir. Sir told that to invent something, there is no age limit. There is no age limit. Like Galois invented Galois theory at the age of 12 years. Sir told that. And Sir told that he is a self-taught person, self-taught mathematician. Though he was died, his contributions are automatically alive. Sir told that. And Ramanujan Park is opened at Kuppam. Sir told that. So thank you, sir, for accepting this invitation and make this program success, sir.
Thank you. Right.
Thank you, sir. Thank you, sir.
Good luck.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Now Jyoti will say vote of thanks. Jyoti madam.
Sir. Mathematics is a powerful tool for every interdisciplinary areas like biology, physics, etc. With this note, I myself and my Jyoti from Mumbai, working as an faculty in maths for degree students. Also, I am the student of Fermat Educational Academy. It is my privilege to propose a vote of thanks on behalf of Fermat Educational Academy to Professor Srinivas sir from Usmania University. Thank you, sir, for your great inspirational words about Srinivas Ramanujan. Also, my heartfelt thanks goes to Professor Srihari Kits Varangal, completed PhD in Kakatiya University. Thank you, sir, for gracing today's occasion. Also, my thanks goes to entire team of Fermat Educational Academy, also to the students and teacher friends of the academy. Thank you, one and all.
Thank you, Jyoti madam. I'm saying a special thanks to Dr. Narasimha Swamy Geetam University for arranging beautiful lectures on 135th birth anniversary of Srinivasa Ramanujan. So thank you, sir. Thank you very much. And Prasad
ma'am.
and Pasha and all my team members, all my faculty members, on the occasion of this Srinivasa Ramanujan, I'm saying special thanks to all my faculty members for cooperating and giving good lectures to our entire Telangana teachers community as well as students community. Actually, we started this program for best platform for giving knowledge to all Telangana students and moreover, almost all our Telugu students. ఎందుకంటే నేర్చుకున్న నాలెడ్జ్ మళ్ళీ మనం పిల్లలకి ఇవ్వాలి కాబట్టి మన దగ్గర ఉన్న నాలెడ్జ్ ని షేర్ చేయాలనే ఉద్దేశంతో ఈ ప్లాట్ఫామ్ తయారనుకున్నప్పుడే స్వామి సార్ కానీ ప్రసాద్ గారు కానీ పాషా సార్ కానీ చాలా కోఆపరేట్ చేశారు. భాస్కర్, విజయ్ వీళ్ళందరం అనుకోనే ముందు స్టార్ట్ చేసాం. థ్యాంక్ యూ సార్ ఫర్ కండక్టింగ్ బ్యూటిఫుల్ webinar or 1 hour webinar on Srinivasa Ramanujan Bhartan. Okay, for this, Swami sir, please speak 2 words about Srinivasa Ramanujan.
Sir. Okay, thank you, sir. It is my privilege to speak a few words about a great mathematician and great dais of Nagesh Fermat Educational Academy. Just of course, today morning in my Geetam University, Mathematics Day celebrations was done, for which Professor G.R.K. sir, G. Radhakrishnamacharya sir is a professor, retired professor of NIT Warangal and IIIT Kurnool, presently working. Sir gave 1 hour lecture. After that, I came to some conclusion that we have so many applications, not only in the physics or in the chemistry, even in our daily life also we have so many applications. So particularly wavelets concept is useful in detecting the cancer, particularly in pathology. A pathologist always, for them it is a difficult role to decide whether the patient when we are sending our some piece of part, when we are biopsy, in the case of biopsy, so for them it is very difficult to take a decision whether it has a cancer is there or not. So in such case, wavelets concept is useful for them. So after that, I felt very happy. Okay, our maths is very much useful in so many aspects, even in the medical science as well as and Sarah also told one more thing, that is at the time of Fourier transformation, every function can be expressed as in terms of sin x and cos x. So that thing also, initially that paper was forwarded to some journal, but the journal rejected that one. And they simply told that it is a ridiculous work. But after some time, scientists realized, and that was published in a reputed journal. So after, like that, our mathematics is slowly influencing in different aspects. In the case of at the time of binary numbers also, binary numbers are introduced initially some years ago, but later that binary numbers are using in the case of computers, because the computers completely based on this computer know only 2 numbers, that is a 0 and 1, because just put on, put off. So that means 0 and 1. So similarly, binary numbers are also using in the case of computers. But at the time of invention of binary numbers, they don't know about how how can they apply in future studies. But after many years, that binary numbers, on the basis of binary numbers, computers invented, and computers using programming, coding, everything. So similarly, in our mathematics, there are so many applications are there. So usually, you know very well, we will speak about pure mathematics, applied mathematics. So whenever we are giving some abstract theory, or whenever we are doing some abstract research, that research we will use that research sometimes maybe directly useful in a daily life, but sometimes it may not useful at that time, but it may useful in future applications. So that is why our mathematics, if we find anything, if we do any research, even single problem, that is also useful in future studies. So that is why, and I also came to know today in morning one thing, that today morning I came to one more thing is that Srinivasa Ramanujam died at the age of 31 or 32. Of course, that I know, but regarding 1729 number, and how he faced because he is a Brahmin, after from, I mean, he came back to London, India from London. He faced some problems from his religion, because they don't want to, I mean, after his death, they don't want to attribute final years to his, but because I mean, he traveled overseas. That is why, according to Brahman, some they don't want to give final years to him. But after some discussions for some time, they also agreed. So Srinivasa Ramanujam personally also faced so many problems because of health, as well as with the society, right? And recent, like it is, I also came to know that of course he is not that much capable in other subjects, but along with maths, he is also expert in biology. So that is also surprised me. Okay, he's. I mean, since now I know that he know only maths, but he is also some good knowledge in biology. However, and one more thing is Hardy, GH Hardy. He worked along with GH Hardy for 5 years in Trinity College, Cambridge University. Trinity College gave almost 35 field medalists from mathematics department, and awarded field medals from Trinity College. And GHRD as well as Littlewoods, they both initially GHRD also received letter, I mean postal material which was posted by Srinivasa Ramanujan to Cambridge University regarding his work. After someone from Madras, he advised him to post that material to GHRD. And on that day, GHRD opened, and he gone through that material, and he simply, it is a ridiculous work. Even Hardy also thought that it is not good work. But after some time in the evening, he discussed with his junior Littlewood, and both sat at one place, and they gone through that material once again. And then they have realized that it is a wonder research in our mathematics, and they wrote invitation to our Srinivasa Ramanujan. Then Srinivasa Ramanujan went. But one thing is, his presentation is not in a conventional mode. You know, usually when we are writing, when we are going with mathematics, we write some. This is a given hypothesis. This is what we have to prove. Therefore, this is the conclusion. In this manner, we will write the proofs, or what are the mathematics proofs. We will go like this. But Srinivasa Ramanujam write his proofs in a zigzag manner. That we have to understood. However, Hardy initially he instructed to write in a conventional proof, instructed to write proofs in a conventional manner, but later they also understood that, so don't want to divert his style, and they also advise write on your own style, then we can see. However, more than 5 years he worked with GHRD and come back to India due to health reason. So, however, we lost a great mathematician in the initial age. I mean, with a short age, he died. Of course, if he is here for more than 60 years or 70 years, then he may create wonders. Not only Ramanujan, usually great people like Srinivasa Ramanujan, Adi Shankaracharya, and even Jesus Christ also died at the age of around 30 years. So anyhow, usually great people always God may think, what I don't know whether their purpose is served afterwards. Immediately they are leaving. So nowadays everyone talks about Srinivasa Ramanujan, and there are some works. Some work is still they are trying to understand the concepts. So, however, Cambridge University also doing many research and in that library also, in the library of Cambridge University also, some 2 to 3 racks completely dedicated to Srinivasa Ramanujan work. Handwritten work is there still. Even in our Tamil Nadu also we have that thing. So anyhow, it is our great offer. Even our government of India also decided National Mathematics Day in the year 2012. When Manmohan Singh is the Prime Minister. So we should say government of India to identify a Ramanujan birthday as National Mathematics Day. We should say some special thanks to our even government of India also. So anyhow, there are so many mathematicians among you also. You can create wonders. Try to do hard work, and definitely our Fermat students, teacher friends should get good jobs in coming notifications. Not only JL, I am also expecting you in set qualifier list as well as DL list. And wish you all the best. And once again, a happy National Mathematics Day to every member of Fermat Educational Academy. Thank you, sir.
Thank you, sir. Thank you very much, sir, for initiating such a beautiful program.